Hello, everyone. We'll go ahead and get started. Thank you for joining us today. My name is Danica. I am with 3C Rent in the County of San Luis Obispo, and welcome to Title 24 Energy Performance Modeling, a peek behind the curtain with our experts Jennifer Rennick and Grant Murphy from Inbounds Green Consulting. Next slide, please. And before I pass things off to them, I just have a few logistical slides to go over. Just a few quick Zoom reminders before we get started. Please make sure you are on mute throughout the duration of the training, and we highly encourage questions. And if any of them do come up, feel free to put them in the chat, or you can raise your hand and we can unmute you. And this session is being recorded, which will be shared with you along with the slides in the next few days. Next slide, please. Just a little bit about who we are. We are the Tri-County Regional Energy Network, also known as 3C REN. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. 3C REN is funded by ratepayer dollars collected through the public goods charge found in our utility bills. And the benefit of being ratepayer funded is that there is no cost to those we serve, and we are able to bring those dollars back into our region. Next slide, please. And 3C REN currently has six programs focused around three services: incentives, training, and technical assistance. Our training today is part of the Energy Code Connect program, and you can find additional trainings and learn more about our other services by visiting our website at 3c-ren.org. And with that, I'll pass things off to Jennifer and Grant to get the course started.
Thanks, Danica. Today, if you are an AIA member, you can get learning units for this course. And if you're ICC, you can also get your CEUs for this course. Today, well, actually, before I get into the agenda, Grant and I both are certified energy analysts through CBECC. We've been doing a lot of energy modeling over the years. And today we wanted to kind of introduce folks to what we do with the energy modeling. Grant has a little bit of a background on how we came up with this course. I'm going to let him jump into it. But just before that, I'm going to remind folks that we'll go over the energy code, kind of this bigger context first. Then we'll look at some of the modeling software structure of how a lot of the software is set up, because we learned that a lot of people don't kind of see that end of it. You know, if they're architects or plans examiners or engineers, they're not necessarily getting a handle on the software. And then we will kind of run you through the final steps that's part of permitting and turn you on to some resources. Okay, Grant, jump in here with this.
This topic came up with from a plans examiner that I work closely with, that he and I go back and forth on the forms and scope of works and what applies and the code language. And he asked, hey, I've never actually seen the software, what you guys are doing to print out these forms and what that looks like. And he has no intention of doing the modeling himself, but he requested that we give kind of that little background inside look as to what we're selecting that impacts the project. So this course is not going to be a how-to model, how to be a Title 24 consultant. There's great resources and classes frequently offered through Energy Code ACE that does a great job of teaching, the ins and outs of actually how to model it. We're trying to give everyone just kind of a sneak peek into what the programs look like and what kind of options your consultants have when they're preparing these for you.
Yeah, exactly. Well said. And also, if any of you do have some experience with energy modeling or any of the software already, we're hoping that if you continue, to stick with us for the whole course today, that this will give you some insight into how we explain it to the folks we're working with, and how we assist people with some of the code coach services in helping them work through their code coach questions, energy modeling, and the actual detail of the code of what's required and not required. And to put that in perspective, just as a reminder, for those who might be new to all of this, Title 24 that we use for our building standards is just one title that is part of 28 titles, part of California. There's roughly 200 regulatory agencies, and Title 24 is the kind of the code world that we live in, although it is related to Title 20 with appliance efficiency standards, and Title 25, where we have housing and community development standards. Now, California has been on a path towards higher, greater efficiency in our buildings, but with this bigger goal of reducing greenhouse gas emissions, reducing pollution, and reducing the quantity and of power plants that California would have to build. And this started back in the 1970s during the energy crisis. And then through this, we had the Cal Green Code was introduced. And right now we're in the 2022 standard for Title 24. And then there's already been legislation in place for up to 2045 to have carbon-free electricity generation. And then the Title 24 Part 6 Energy Code, well, it has a process. It doesn't just happen every year, it's every 3 years. And so coming up in January of this year, 2026, we're going to have the new 2025 Energy Code take effect. And today, because we're still in the 2022 code, we're going to use that as an example, but just kind of give you guys a big highlight is that the big picture goals that California has for our energy code right now is to encourage heat pump technology for space and water heating, to establish electric ready requirements, and expand our PV and battery system storage standards, and all the while improving indoor air quality by strengthening our ventilation standards. This push towards all electric is because our electric grid is depending more and more on renewable energy and less on fossil fuels, less on burning fossil fuels directly to create the energy. So with a cleaner energy grid, it makes sense from California's, big picture perspective to encourage and embrace the electric technologies. Before we dive into this, there's 3 terms I want to review, just kind of case for those folks who are new to this, is that in the energy code, we often are talking about 3 things that we may need to comply with. One is a mandatory measure, and that's something that applies to all project types and across the board. So something is mandatory. And then there is something that could be prescriptively required, or something that is performance method required. Now, prescriptively required means you're going to follow more like a checklist approach, like a recipe card. So if you go that route for your building to comply with the energy code, then you do all the parts that are part of that prescriptive component package. Or you can do a computer energy model, which is what we're going to talk about today. And that's more of the world that Grant and I live in when we're working with our private clients. And so we engage in a computer model and model the energy use of that building. California has a process for what software is allowed to be used for energy modeling. And you can learn more about that by going to the California Energy Commission website. And right now for the 2022 code, we have CBECC Res for the residential code, and that is free software that the state maintains. Then we have Energy Pro, which is private software, but now this is a change. When I first started out, everything was like Energy Pro, and now what it is you interface with the software Energy Pro, and it's basically running or communicating with the CBECC software in the background. And same with the Right Energy Title 24 software package. And then for our non-residential multifamily, again, you can use Energy Pro and CBECC, which is the free software available to anybody, or you can purchase IESBE software, and it also then interfaces with CBECC, running that engine in the background. When we do our performance modeling, we have results and we have certain metrics that we have to meet. And this is just an example for residential that we have 3 metrics, and we have to model our project, which is our proposed design, but it gets compared to a standard design. And so standard and proposed are compared to each other with these 3 metrics. And one of them is called the EDR, Energy Design Rating, and it's source energy. It's trying to get a handle on how the energy impact is related to how our energy is created. So there is a fossil fuel carbon kind of impact on how we use our energy, even when we're pulling it from the electric grid. And one of the other metrics then is just how energy efficient your building is compared to the baseline. And then our total efficiency includes PV and battery component. And by PV, I mean solar panels or solar energy created on site. And so when those 3 metrics show that our proposed design uses less energy than the standard design, then we have a compliant building. And a lot of times when Grant and I are working on these projects with the performance method, or your consultant who's doing your Title 24 energy calcs for you, we're looking at the energy use details and how certain regulated loads are performing. And for California, our regulated loads are the energy that goes into space heating, space cooling, ventilation, water heating, and then there's something, now we have a self-utilization or flexibility credit that has to do with your a battery on site. And then we have required photovoltaics, battery. There's a flexibility component in that with how the photovoltaics and batteries are used or how it's controlled. And then we have some loads that are not regulated. So we may have requirements for inside lighting, like it needs to be LED lighting, for example, certain control switch, but we don't actually model the lights in residential like we do in multifamily. But these extra loads, like your appliance, your cooking, your plug loads, and exterior lights are there for information so you can understand more about how your building performs. So we create a standard design. We have a standard design that is automatically generated based on our proposed design. And then those energy uses are compared. And for the compliance margin, if we see a negative, we know there's some room improvement, meaning our proposed design uses more energy than the standard. And because these loads, you can trade them on and off. If we, in this example, we have a positive number for the PV and battery component, we overcame those negative values. And so overall, we have a positive margin compliance and the project complies. And it's a similar concept for the non-residential buildings. And they use a PDV metric, little different than the EDR score, but the concept is similar. Okay, anything you want to add to that, Grant, kind of as a little background?
I think it's just, yeah, I think it's worth noting that we're going to be looking at residential today. The non-res, I think majority of these screenshots are using the Energy Pro software. The paid for software, the interface is a little bit easier to look at. It's worth noting that the CBECC one is relatively, like, the inputs are the same. Um, but we're going to be focusing on res. It's a little bit easier to handle. This is our first time doing this course. So maybe if we have, engagement and people enjoy this, we can come back with the non-res version. But there'll be a couple items on non-res, but we're really going to be looking at residential performance models.
Yeah, that's right. And so what we've noticed over the years is that, like Grant was saying, we'll get questions about what folks should pay attention to on the compliance Title 24 documents that they use for permitting. And we realize that a lot of those questions that we get is sometimes a direct result of those folks not really knowing what we're choosing from, what options we have, or what information we need to use the software. To us, it seems more straightforward, but not, for everybody else. And then I want to, kind of an aside is that the CBECC res and the software available now all have kind of what we call a building tree structure to them to use the software, which is a huge improvement. So the folks that are been doing this as long as me, when I first started out, there was no building tree structure. It wasn't visual like this. It literally was a bunch of spreadsheets and line item inputs, same information, but not really set up in a hierarchy like this. And so what we're going to kind of show you is one of the little peeks behind that curtain is what does that hierarchy structure look like? So for the CBECC res, you've got an envelope tab, and then there's a hierarchical structure to all the inputs, the attics, walls, your garage space, PVs, etc. And then there's a mechanical tab where you would put everything that is related to your heating, ventilation, air conditioning, your water heaters, etc. Under Energy Pro, and this was kind of the first software to set up this hierarchical structure, but it was running a different engine in the background at the time. And this software became popular because the visual building tree made it pretty straightforward to kind of see how you were modeling your building, and you could easily come back and find what you needed to find, as opposed to spreadsheet approach, which is how I learned. And with this just slight difference, the mechanical systems are just embedded within the Energy Pro building tree instead of being on a separate tab. And today, like Grant said, we're going to focus on Energy Pro as a means to describe what goes into modeling a building. And give you a closer look at this for the building tree. We start out with this sort of top level with a lot of building information. Then just below that is the plant level, or your domestic hot water, and plant would also include like chillers for non-res projects. And then there's the HVAC, heating, ventilation, air conditioning, kind of mechanical tab. And then below that would be the zone that mechanical system is serving and all the information that's applicable to zone level. And then you can start to create rooms inside of the zone. It could be one room, it could be multiple rooms, depends on your project and what you're doing. And then part of that room level is your roof, attic, walls, windows, floors, and for non-res, interior lights and interior surfaces. But that kind of gives you the sort of the hierarchy of how this is laid out. top level building tree. That's where we will put in project information, the address, figure out, enter your climate zone information. If it's a residential project, you would have HERS measures. So those would be things that might be required to have a third party come and take a look at while the house is under construction, or these could be extra credit items that you're pursuing under this performance method. Then there's some things that may not necessarily seem related, but the way Energy Pro was set up, we also would have a reference to whether we're using a balanced ventilation system, are we using night vent cooling, PV batteries, and some other topics. And I'll run through that here in a moment for you. But one of the first things you need to do, no matter what, is find your climate zone. And if you are new to this, one of the easiest ways now to find your climate zone is the California Energy Commission has an online tool called the Easy Building Climate Zone Finder. You can enter the address and it'll let you know what climate zone you're in. And then if you go to the reference appendices and you're really into it, you can find out more about median of extremes, your heating degree days, etc. So on that top building level, you've got your project design data. You're going to tell the program what the status of the building is and what we mean by that. And this directly parallels the Title 24 performance pathways of whether your project is new construction, whether it's an addition, or if you're going to do a project that's the existing conditions plus addition and alterations. And so those, per Title 24, Part 6, those are your only choices there. And of course, you're going to enter your climate zone information. And then there's some other information like ASHRAE building type, etc. And that is there because the software allows you to run other types of calculations in addition to Title 24 performance. And so today we're just going to focus on those Title 24 performance inputs. And we'll also have tabs for your title of your project, your designer, architect's name, lighting engineer's name, mechanical engineer's name, etc. And then under the miscellaneous tab, this is where we have some of those other features that I mentioned. And then we'll have a PV battery tab we'll take a closer look at. But under this,
Jennifer,
yeah,
real quick on that back one, we already had a question, which is great, Sean, and anyone else in the chat. And if you see something, you're like, hey, what is that input? Feel free to chime in. So for the rotation, because there are some that we're gonna kind of brush over, but this is perfect. The front orientation was developed, and your options are just cardinal degrees of direction. It was originally put in there, so on the report, it prints what direction the front door is. I believe the intention was so a inspector knew where the front door was. The rotation below that shows 0 is actually what dictates the rotation of the home. You'll see later, much later in the presentation, when we get to assemblies, you orient the individual walls themselves to be north, south, etc. That rotation allows you, as a modeler, say you input everything cardinal 0, 180, 270, 90, and then the whole home is 20 degrees off of that, you can rotate the entire model without having to go in and alter every single wall that you input. So it's kind of just like a little time saver efficiency thing they added to it. You can keep going.
That's right. Yeah, good point. And then like in CBECC, if you're in CBECC Res, a lot of time it's a little different, but same concept what Grant said. And you would have like front orientation, right-hand wall, left-hand wall, or back wall. And the whole idea on the residential stuff was supposedly to make it easier for someone who's going on site to go, oh, that's the right-hand side of the building, or the back of the building, or rear of the building. And
Jennifer, we had another quick one. When would you use the project as no dwelling units, no DHW usages included? I've never actually used that button, so Is that a non-res specific option?
Well, some of the U occupancies that are, it
Yeah.
has to do with planning, what's going on with your planning department. So if you've got a U occupancy, like a barn that's got a conditioned little gym and their office and another bedroom, bathroom. I mean, sorry, not the bedroom. It's got the bathroom and stuff, but it's part of this big project. You might have to model that building, and it's not going to have a bedroom in it. It's not a
Okay.
dwelling unit.
Yeah, that would be something like in
But
some of our other courses that we do when we're trying to identify like more from the forms perspective, what to look for. If you saw a form that had something printing that says project has no dwelling units, that to me, if I was reviewing, would be not a red flag, but something that I'd want to check and verify and be like, oh, that's different than normal. Let me see that
and
this
it's
is
not an
valid.
80, right? And then if you're
Right.
wondering, like we've had projects, like we could go into the weeds on it,
Yeah.
but it's like we've had that come back where plans examiners like, hey, it says it's no dwelling units, but I swear this is going to be an ADU. But now
Right.
ADUs are legal, so we don't really see that so much. But back then, I mean, some years back, it was something that came up.
Okay, let's keep going.
Yeah, and so some of the software, so interesting, kind of this metamorphosis of Energy Pro. Some of these things are in there for non-Title 24 Part 6 compliance because you can do other things with the software. And then some of these buttons are still there that have been there forever, that are left over. And then there's some new stuff that I'll show you that seems slightly out of place, and that's because like this miscellaneous tab, it's like, well, this is just as good of a place to put it as any, just because of the way the software was set up, the user interface was set up years ago. So like this miscellaneous tab, for example, from our perspective, we come to this tab all the time for residential projects because we're going to determine what PERS measures this project might go for. So quality insulation installation is part of that prescriptive requirement for the climate zones we work in. But we want to make sure we click that box, for example, because we don't want to take a penalty for not doing QII in the performance method. But sometimes we have clients who explicitly say, I don't want to do QII. Can you unclick it? Then we have to do other things to make up for it, for example. And almost always a new construction is going to have a kitchen hood. Okay, so you need to make sure it's clicked anyway, so it'll calculate that. And also, if you're doing existing systems. So that's the kind of things that are on this tab. So some of those HERS measures, for example, QII we just mentioned, but there's envelope leakage testing, which is a blower door test, and then having those existing conditions verified. But the kitchen hood also triggers HERS person to come out and see that it's got the proper CFM airflow and that it's HVI rated, which is part of the 2022 code and will be part of the 2025 code. Okay, there's information here for crawl space if you have it. If you don't, then you ignore that. It might be a slab on grade. There is also, this is the place where you click this box if you're going to have a balanced ventilation or heat recovery system for your indoor air quality, outside air coming into the space. Just kind of put a pin in that because another part of the software refers you back to the top level of the building tree, but you got to remember to go to the miscellaneous tab to click it. And then there's a few items that we don't use very much in our Tri-County region, but for folks, if you're outside of the Tri-County region, you might deal with ventilation cooling or occupant controlled smart thermostats for that pre-cooling. And typically for us, that's just left as none and unclicked. Okay, and if we're then the next kind of tab that's really a little more specific to residential is the PV and battery. This This tab is also for non-residential applications and kind of put it all together. You might see up at the top, there was a reference to utility or outdoor, exterior uses, pools. Like I was saying, the software can be used for other purposes. So those tabs you would visit if you were going to use a pool and want to know something about the energy use or the outdoor lighting types. And your utility schedule. Like, let's say you knew exactly what rate you were on with PG&E and you were doing a lead project, for example, you'd go in and use those tabs. But for residential Title 24 compliance, skip all that and we come to the PV battery tab and we input our solar panel information here, like the size, and if we're taking any exemptions or exceptions to it. We can input more detailed PV information in this part of the software. And then if they're taking a battery or installing a battery rather, then we would put our battery information here on this portion of the tab. This little box is the one we click for the residential battery taking extra credit. I didn't do the pull down menu on the controls, but the basic says it does not feed to the grid. But these days, most people, when they install batteries, they're actually wanting it to feed back to the grid. And that's part of the requirement. So that you would also need to address that. So there's a lot to know just on how to deal with the PVs that we don't really have time for today, but this is the kind of information and this is where we input it. Yeah, go ahead, Graham.
Jennifer, real quick, what is the input for the rate? What defaults as 5 kW as an input?
It just defaults to that. That is specific to the battery, and there's a discharge and a charging rate. So some battery systems can accept recharge quicker than others, and it can also let that energy back out quicker than others. And this is kind of typical for a residential scale battery, but those numbers change a lot when we're doing multifamily and commercial. And it's very specific to the actual battery that gets specified.
I think that's a good takeaway that'll be reoccurring, where a lot of these things we're showing you what what we have control over and what we're looking for, um, when inputting, and a lot of the times it comes back to, hey, we need an actual make model of whatever appliance or unit we're talking about, and that has to come direct from a cut sheet from a manufacturer, etc. So that charge discharge rate was something that was kind of a pain to find. And now it's becoming easier as people are installing more batteries and more accustomed to this.
That's right. And then
And
the round trip efficiency value
right,
also was
right.
something that wasn't that easy to get a hold of, but now is. And
Yeah,
kind of tagging on to what Grant said, I mean, for a residential project, if you don't know what they're doing for a PV system and they haven't said they want a battery, you just leave the battery stuff blank and you just let the software tell you what size PV system they are going to require. But if they already have a designer, they already know what they want to do. And if they're installing maybe more PV than the code requires, then we can put that in to the software and show some credit.
great.
And so this is really specific to product. Okay. And that's kind of a similar theme for hot water for domestic use, which we'll show you in a moment. But also on this sort of plant tab here, we've, named it, it's DHW, residential domestic hot water system. But if it was a non-res project, this is also where you would enter your information for your chillers and cooling towers and space cooling. And also where you could enter information for hot water heating systems for space heating. like hydronic floors, for example. So the heating, hot water, kind of, this is when you click it, this is sort of the first tab that opens up. And typically this is the part we ignore for single family. It's just you get used to using the software, so we don't worry too much about this. But if you did have a non-res project, I mean, this is where you would input your information for your boilers and the pumps for the space heating information. If your project is using a hydronic gradient floor heating, then you would click on the hydronic tab and fill that out for your home. But otherwise, we're just looking at domestic hot water. And there's two tabs for you because some projects have two hot water systems. If you have a really big house, for example, or if it's situated so that one end of the house has a group of bathrooms, utility room, and then say there's another master bedroom suite far, far away, and maybe that's also near the kitchen, you might have two hot water heaters that are different from each other. So it just gives you that flexibility. That's what that's about. Now, on the domestic hot water tab, DHW boiler, it's called a boiler, but a lot of times we don't think of domestic hot water, you know, your 50-gallon old style gas tank, or maybe a 50-gallon heat pump water heater, or an on-demand gas unit. We don't really think of it as a boiler, but it is called that. We have the status, and then where it says new boiler and multiplier, how many of them do you have? It's undefined right now. So we're going to go in and take a look at what options we have for that. And then there's some questions about where that hot water heater is located. This specifically important for heat pump water heaters. And then there's a whole little section that's grayed out right now if you're going to have solar hot water or solar thermal. You can fill that out. And then there's a portion that's related on how is the plumbing distribution set up in the house. And then there's also choices on compact distribution. And this is where some of these HERS credits can come into play. And for this distribution type, there are a number to choose from. And this is straight out of like the Part 6, Title 24 standards. And each of these types of distribution has an implication on how the energy use of the hot water is modeled. And we'll go, I'll show you what that looks like here in a screenshot or two. And then, pardon me, this bit that's grayed out, it will ungray if you are doing multifamily or hotel motel and you have a central heat pump water heating system. And then there's another part of the whole screen we didn't show. That's more entailed. And like Grant said, if there's enough interest, we could include some of that in a future class, because it's more entailed than we have time for today. But back to like what you would do for a single family residence and choosing your hot water heater, you can pick from kind of a default menu, or you could build your own system if it's gas-fired or electric resistance, and you can give it a name you want. So for example, defaulted into the software, but you could choose anything you want. This is just called standard gas tankless. Great, it's got 1 gallon, has an input, uniform energy factor 0.81. It's kind of the minimum. You're set if that's the direction your client wants to go. But if you're going to be modeling a heat pump water heater, then you will click the select the NIA for NIA heat pump or NIA HP. And these products are gonna populate. And you can see on the left-hand side, there's something called generic. And then after that, it's brand specific. So with the brand specific options, you are limited on what you can choose because each of the items in the software, and this is true with the CBECC res, then they've been certified by the Northwest Energy Efficiency Alliance. You can go on their website and also learn more about those products and the tiers and the efficiency. And this is where, because it's brand specific, we often ask our clients, do you know what brand of heat pump water heater and model you want to use? And if they don't, then we can come back here and just pick a generic tier, 50-gallon, 40-gallon, 65, 80-gallon tank, and look at the UEF or the efficiency rating on it. Or we choose a very brand specific water heater. This is in contrast to what we can do with our heating and cooling system, for example, which we'll get to in just a moment. So once you know that, then you pick that water heater and it populates there on that part of the chart. And then we come back in here to the water heater location and we choose its location. And if that heat pump condenser does pull air from the outdoors, if it's a ducted unit or if it's a split system where the condenser is outdoors, then we would click that because that also is directly impact on your energy calculations and shows up on the forms.
I want to make a note here because Sean's asking a good question, one that I don't think we can fully detail out right now, about how on the forms it prints out where that air is, where the tank location is, incoming from outside, incoming from garage, etc. The printout is kind of wonky. Certain things, I believe if I remember correctly, if you pick garage, it says inside. And if there's another one that like it doesn't necessarily match perfectly, there is credit and penalty associated with the compliance for this. So a heat pump water heater performs better in a higher ambient temperature installation. So when you are selecting that the intake air is coming from outside, it will, not a dramatic penalty, but you will see a reduction versus if you're saying that the intake air is from the inside of the building. If you change that drop down where it says garage to inside, then it allows you to pick a room from your building tree where it is. I'm just going to table that comment, Sean, just because I think it's worth maybe doing a little write-up to show what options print what. But it's not a very straightforward answer, unfortunately, and that's a common question and comment that I hear from plan checkers and Tile 24 consultants alike.
Yeah, that's true. That is true. Close up, kind of a close up now on the distribution types and the HERS rater. So that pull down menu, we do have to choose a type. Most of the Title 24 forms we see, standard is chosen, which just means there is no recirculation pump and no need for HERS and folks to come out and take a look at it. And then typically what we see, however, is or we'll get a call that says, hey, I just went out to the site and I noticed there was a recirculation pump on that heat pump water heater, but it doesn't show up on the forms. Then we have to rerun it. Why? That's a big deal. And so we're kind of giving all our architects a heads up on this, our builders, our plans examiners a heads up on it. Because it turns out that if you choose certain options, you can get a credit. And if you choose recirculation pump, it technically comes as a penalty. And so this table, I included it with the slides. It doesn't show up in the software. This is like, okay, for those of us doing energy consulting, we're supposed to know this. So multipliers less than 1 are an energy savings, and multipliers greater than 1 is an energy penalty. So you can do something, compact plumbing or point of use plumbing. I'll give you an example of what those are. They're less than 1, the multiplier, you get a credit. So that's a great thing. And all of these, hers isn't required. It's supposed to just be straightforward on the plans. So it does put a little pressure on the plans examiner to know what the compact plumbing is or the point of use plumbing is, or ask the designer to prove it on the drawing to you if you see it on their Title 24. And then with the no hers recirculation pump, each of these come as a penalty, but some are less so. So for example, recirculation with a manual demand control is the option that's least penalized in this case, with a 1.75. So they'll take that hot water use, multiply it by 1.75 and compare it to that standard water use, which doesn't have the 1.75 multiplier attached. So if you do the hers option, it comes with less of a penalty than with the hers, than without the hers option. But similar, if you do the hers inspection and you do that compact plumbing or expanded credit and pipe insulation, and you want to claim that that's done, hers rater comes out and looks at it, you get some credit. And then again, with the recirculation pump, even with the hers measures, you still get a penalty. It's just not as steep. And this, yeah, go ahead.
Real quick on the one previous, so my conversation with people about recirc is, if you do recirc with no controls, you might have seen it was like a 9 point something penalty, and it is really
9.8. I'll go.
really difficult to pass a lot of projects with that without doing substantial other stuff. Those two control options they're giving you, one, the manual is push buttons, so it's push buttons located at fixtures. The other one is motion sense instead of the push button. Uh, I've had no one ever want to do the motion sense. Push buttons is rarely. The reason I bring this up so often is because I hate when projects, unbeknownst to whoever it might be, have a recirc when we didn't think so, included a recirc, and then there wasn't one, and they had to do a bunch of other stuff to overcome that. If this gets caught in the field, it's just kind of a snowball effect, and everyone's mad at everyone. So we try to get ahead of this as best we can.
Right. So we kind of give that warning out there to anyone who's like, do you do hers? You probably know that already. If you do energy consulting, yeah, you know that already. And then the plans examiners, the architects, engineers, like and the builders, just beware, just look for that. It really snowballs in a bad way. But if you do the hers rating, and so like with one of the hers raters we work with, when that's caught, it's like, okay, here's the deal. He has a conversation with the builder and the owner, and so then it morphs into a hers verified push button type, on demand type. So it has the least penalty, and then we do something else to make up for the difference, is usually what happens. But it's so much easier to catch it early on. This is just the kind of thing the hers rater would look for if you're going to take that verified compact hot water distribution credit. And part of the reason we recommend doing compact plumbing, whether you take credit for it or not, is because a lot of times if you do compact plumbing, meaning the hot water heat pump hot water heater is very close to the fixtures that require hot water, in those systems, a lot of times you don't need a recirculation pump anyway. And so then some of the things to look for is on the plans really should have these distances called out on the plans. And then these are the same distances that get input into the Title 24 forms that show up on the forms that your HERS rater and installation installers are actually going to be looking at. And then eventually the plans, you know, the folks at the county or authority having jurisdiction signs off when all these things get populated and approved properly. And with the point of use credit, this is where the plumbing and the plumbing fixtures and your hot water system are very, very close to each other. And where this is coming up more and more is point of use plumbing is a requirement for taking an exemption for ADUs that are less than 500 square feet or an addition that's less than 500 square feet. For example, you can use an electric instantaneous water heater in those cases. You don't have to use a big heat pump water heater for such a tiny space, but you absolutely have to use what's called point of use plumbing. And this is where architects come in, plans examiners, because somebody somewhere is supposed to show that the length of piping needed, and based on the nominal dimensions, that line size versus length for each run takes the most direct path and is within these length parameters. And so usually the way that's done, it's directly right from the hot water heater this is an example of a PEX manifold system. And this has more piping than you would see on a small ADU, but it's an example of what it looks like. And so that comes right off the hot water heater, and then it directly breaks into the small diameter pipelines for the fixtures that are needed. So that's a thing too that impacts the authority having jurisdiction and the designer technically. But we haven't been seeing it marked up on too many plans. So, you know, you kind of have to, sometimes it's by scale. So we're recommending to the architects and the designers just to put that on your plans from the get-go so that you show compliance and your energy modeler knows that you've done it. Now, the next kind of level down on the building tree is your HVAC systems for space heating, space cooling, its distribution system, those HERS credits that are related to it. And then there's some additional features for the non-residential systems that also populates on that level. But in general, this system for mechanicals, this is where you, like Grant said, you get the cut sheets from the mechanical engineer or the manufacturer or the person doing the installation, your builder, and you can create a system that matches those cut sheets, give it a name, and you model it that way. Unlike the water heaters where it's already, you have to pick a brand and a system because of the way those have been evaluated through NEA. So take a look at the general tab, the distribution, get similar thing, its status. Is it new? Is it a remodel? Is it a replacement? And we'll create something in the library. And then there's part of this that's used for the non-residential occupancies, like if you're doing ASHRAE or LEED or some other calculations. And for this particular system, we're going to just say, hey, let's look at a high efficiency heat pump. We picked that from the library. This was one of the ones that was kind of input as a generic placeholder that you can use. But here, the user really creates and names the HVAC systems, and you can build your own custom libraries to have on hand. So we've built them where we have like split system heat pumps we use for homes that kind of fit what brands we know are typically chosen in the area. And then once that is really chosen, we can fine tune it. And so I'm going to take a close up look on this part of the window. So heating tab, cooling tab, controls, outdoor air, fans. Those are the systems we're dealing with typically for residential systems. Typically, we don't have evaporative cooling in our area. The system type, that pulls down menu. So this follows, your mechanical heating, cooling types, whether it's a split system, package system, variable refrigerant flow, hydronic heat pumps, chilled beams, etc. So you choose that. And in this case, we're going to look at a split system, meaning outdoor condenser, indoor air handler, and it's electric heat pump, but that's also a pull down menu. Could be gas furnace, electric resistance, could be a dual fuel heat pump, which has both fossil fuel and the electric heat pump, etc. And we fill out the information for the output for heat pumps, 47 degrees Fahrenheit output, and the output at 17 degrees Fahrenheit, and its efficiency, etc.
Yeah, and so the majority of the time you're going to see this modeled as a split DX for residential. It's pretty rare to pick something else. Most of those other system types are used for non-res calcs. So even in the case that, let's say, you have a gas furnace or some kind of older gas appliance, if you're doing an alteration or modeling an existing system, you would still select that split DX, and then under the heating type you would select that gas type, and it'll change what the efficiency metrics are that you need to input. And this is just the heating side. So you can build out this heating side, but then once we get to the cooling tab, you'll see you're building out the second side of it. For a split DX electric heat pump, they're going to look really similar. You're going to have your sear ear on the cooling, and you're going to have your HSPF on the heating. And then those capacitors are going to align with that single piece of equipment that does both heating and cooling.
Right. And then the controls, whether it's running continuously or intermittently, and then the fans would have your how many watts or the horsepower for that blower inside that unit. And so each of those tabs, there's a lot going on, but this just gives you an idea of like high level. As an energy modeler, we're choosing from standard, like agreed upon. The industry knows what each of these things mean, and you pick your type. So,
and I think it's worth noting too that some of these things do kind of hidden not trigger, but are associated with your HERS rater. So one that's come up recently is that total output, and that output at 17 degrees. So there is a HERS verification where your HERS rater comes out on site and is just verifying that the unit that is input is the one that matched the plans, that matched the Tile 24. So every unit that's
That's right.
purchased has a capacity rating and has a rated capacity tested at 17 degrees. And so commonly we'll have, hey, my contractor put in a different, split system. The capacities are slightly different. Can you revise the Title 24? It's not something that usually dramatically changes the compliance of the project. So it's really like a consistency of design through finish. And a lot of HERS raters, they don't want to just sign off on saying, hey, this isn't what it doesn't match. Like, please give me something so I can match this. Otherwise, on their side, when they're doing their HERS forms, they run into issues. So that consistency through the process is kind of the goal. And then another note, also, a lot of energy modelers will put in lower HSPF SEER ear numbers than they anticipate from the unit, there's no problem doing that. If your project complies with minimum efficiency ratings and you put in a more efficient unit, that is allowed. The only issue that comes up is when it's the opposite. So some people have learned that instead of chasing that exact number, knowing that there's changes in field, they'll just select a minimum, get the project to pass, and say, as long as you have a more efficient unit than the minimum, you're going to be okay on your efficiency ratings.
That's right.
Single phase, we just had a question come through. Does the CR2 ear 2 button and single phase buttons, if those are left unmarked by accidents, does that affect the calc? So the single phase does affect it slightly. So that's something to note. Majority of residential units are going to be single phase, but something to be sure of. And then, yeah, one sec, Fabian. And then the SEER Ear 2, that is the new efficiency rating, SEER 2 instead of SEER. If you don't click the using new HSPF 2, SEER 2, Ear 2, where it says efficiency, it'll default back to just HSPF. So depending on the unit you're purchasing and installing, some of them might not have the tested conditions for the new efficiency rating. So you can still use the old one. You just want to see on your cut sheet, does it say HSPF or does it say HSPF 2? If it says 2, check the box and input the one. Fabian,
Yeah,
give
and
me.
there is, yeah, and that's a kind of important because you might be bummed. You're like, oh shoot, I forgot to check the box, and then now you get that problem where one way or the other, the unit installed looks like you're trying to claim that you have a more efficient unit than you did. So it's just telling it which units you're using. You want to be consistent. Okay, I'm gonna move on to distribution. So another part of that tab is how, and then I just excerpt the part for new because there's a part in this for existing distribution, which isn't really applicable to us. And then there's another similar like pull down menu for non-residential distribution. But right now we're just looking new residential distribution, and you can have ducted systems or ductless systems. So if we look take the heating distribution example, right now we show it as ducted, but you could choose a ductless with a fan, like a wall mounted mini split, or ductless no fan. We don't see too many of those for heating at all. Radiant floor system, baseboard heating system. Typically, we're just dealing with ducted or ductless, like wall-mounted mini split with the fan. Cooling has a similar distribution. If you do have ducts, then you can click whether you have less than 12 feet of duct in unconditioned space. But in this case, when we're looking at the duct location, we're saying, no, all the ducts are in conditioned space, but there's also a pull down menu here, and you're just limited to choosing conditioned space, outdoors, crawl space, garage, attic, or in indirectly conditioned space. And then for our duct leakage, another pull down menu, and those choices are duct leakage non-verified, but again, that's for the non-residential occupancy types. But for our residences, it's usually sealed ducts with leakage verified, or we might have a low leakage air handler with the leakage verified. And then ducts in conditioned leakage to outdoor air less than 25 CFM. But typically, we're just dealing with sealed ducts, leakage verified, or low leakage air handler with leakage verified. And those do trigger HERS inspection or HERS verification. Oh, also we choose the insulation level around the ducts in that same tab. But to give you an example, pick that low leakage ducts in conditioned space, for example, same options for multifamily projects. Now your HERS rater is going to come out and look for the visual inspection of the duct location, and then they're going to do duct leakage testing to show that the ducts are meeting the low leakage part. Plus, they want to see that the ducts are truly in the conditioned space. So in other words, those ducts need to be located, like in this example, below the ceiling plane, which will be taped, drywalled all around so that it's within the air barrier. And then those ducts are going to be within a soffit. That gives you an example of that. And then these are populated on the CF2R, CF3R forms, which is part of that whole permitting process. And then, for example, if you are clicked or triggered one of those HERS measures where the duct leakage diagnostic testing is needed, like we said, the low leakage ducts in conditioned space, then once the system is built up and the envelope is taped, sealed, ready to go, then the HERS raters can come out and put their flow and pressure gauge onto the duct system and cover the supply ducts with these special caps, or tape it off and seal it so that they can really just get a good pressure reading on the ducts and prove that the ducts aren't leaking. If they're leaking, then you come back and you work with the installer to fix the leaks. And then the HERS rater also, as part of all this, is going to be looking at the capacity and the efficiency of those air handler and the outdoor units to show that that also meets those requirements. And they may also have to do refrigerant testing, depending on, or verify that the refrigerant was pressurized and tested properly during installation as part of those HERS measures. Okay, so then kind of moving along, after the HVAC tab, then we get to this zone tab. And for residential, there isn't a lot that gets put into information that get put in here. But for the non-res, you're going to also have your lighting and your schedules and other kind of building level information. So what that looks like in Energy Pro is this screen. And so we've got our zone details where we choose the occupancy type. And in this case, it's single family, whether that zone is conditioned or not. So you can have an unconditioned or semi-conditioned zone in your non-residential occupancies, but typically, residential, you're going to pick that it's a single family dwelling type. You select that occupancy as single family and the zone is conditioned. Kind of end of story there, but pardon me, almost the end of story. We also need to tell the software what floor this zone is located on and how many stories this building may have. So if it's a single story building, 2-story, 3-story building, for example. And then the envelope status, lighting status, that really is going to show up as, new for new construction. And those come into play with the, for the other types of, whether it's existing or it's a remodel, and also for your non-res occupancy types. And then this little button that the arrow's pointing to was put into Energy Pro just to clarify if this is an accessory dwelling unit. But we're actually going to, we actually teach some classes on how to deal with the modeling for ADUs. Right now, we're doing a single family residence as example. So no, it's not an accessory dwelling unit. And then these other parts of this page really is for the non-residential occupancy types. So again, we're going to kind of brush over that. Now on this zone tab, the one thing that comes into play for the residential occupancies is this dwelling units. And this thing has a lot of information on it that you need to take a look at. And it's over the years, it's gotten a little more and more crowded, but they've just kind of put it all into this dwelling units tab, which at the zone level. I don't know if it makes sense to put it on this level, but this is where it is. So kind of a mental note if you're new to it and you want to play around with the software. Your dwelling unit information, you give it a name, you tell it the floor area. This is used for calculating the loads, the heating, cooling loads on that zone level that impacts your HVAC sizing. So you would tell it whether that zone included that domestic hot water tank, for example. And this is where you tell the software what appliances are located within that zone. And you can choose, that's the range: refrigerator, dishwasher, in-unit washer, in-unit dryer. And also you could choose, if you're modeling a dryer, a range as electric. So we often will pick electric when we're trying to get a handle on that predicted energy use when we do all electric. Otherwise it defaults to natural gas. This is where we kind of put a pin on that high level building tree. If we chose we were doing balanced ventilation or not, then we click that button, we come back to this dwelling units tab, and we can choose for our indoor air quality, our outside air, if we're just doing it as an exhaust only fan, a supply only fan, or balanced, and whether or not it includes heat recovery. So you can fine tune your ventilation system, or you can choose to use a default. And then similarly, if it's a multifamily project, this tab will ungray. And then this is where you would enter shower drain water heat recovery if you're doing it. We don't typically see this in our mild climate zones for the Tri-County 3C REN area. This is a way to save hot energy at the hot water, so it will capture the heat that goes down the drain from your shower and recapture that heat and feed back into your hot water heating system. And as we mentioned before, under the domestic hot water heating distribution tab, you would click that compact plumbing. It's actually in the zone level that you would come back and depict those distances from that hot water heater to each of the appliances to get that credit. Okay, and then that brings us to the room level, which is fairly straightforward. This room level also is part of the internal loads for your heating and cooling system. So this is where you can tell the software how many people are expected in that zone, which is typically used for the non-residential occupancies, your plug loads, process loads, whether you have hot water impact, and your lighting loads. Again, most of those are for the non-res occupancies, but this is where you'd find it, is in that room level. So for residential occupancy, usually what we're just looking at is what's the floor area of the room. Okay, then we move on. It's pretty straightforward. And then you'll see here they've got like installed LPD, that's lighting power density, 0 watts per square foot. Again, this isn't going to populate unless you're doing a non-res occupancy, and then you're actually specifying what lights are in that room at that level, and then that'll show up. But for houses, we can largely ignore it. Now that next level down of the room, this is where we get into our construction assemblies: roof, walls, doors, windows, raised floors, slab on grade, interior surfaces that separate your stories, or interior walls, or like the wall between your house and the garage, for example. That's where we model all these. And it's fairly straightforward, but we can create and name these building envelope assemblies. So a lot of times when we're working with the jurisdictions, we remind folks that just because the name, for example, says it's an R38 roof or R38 HP attic, we give it that name and we pick it and we dictate what that is. So we tell the folks, don't worry about the name. Take a look at what kind of U value, what U factor this has, which means there's a layer for the plans examiners and the architect to understand thermal heat transfer and what a U value is. But there's a code coach service, and we can help you understand that and point you to it. But just know the name, it's supposed to be helpful for the energy modeler, but we can call it anything we want. So what we do is, like on this residential performance tab, we do say, hey, use R38 ceiling insulation, for example. We do take a look at the attic, if there is an attic, and determine is it unvented or vented and what the heel height of the truss is. We'll take a look at that insulation and whether there's exterior rigid above the roof deck or added insulation below the roof deck, and what the cavity fill insulation is. And then there's an other category that has to do with the project has spray foam. Okay, so this tab is used for your performance method. And then there's a layers tab where we can actually go in and layer all the building components, parts, and pieces for that assembly. Now, this tab, the layers tab, is used for your non-residential compliance calculations. But for residential, it just grabs it in name only and it populates it on your Title 24 report, but it's not actually using it for the calculation. So we just get a lot of things that come back to us saying, hey, this is a metal roof with a layer of Dens deck under it. How come your Title 24 report says asphalt shingles? And we go, oh, it just defaulted from the layers tab. That's what we mean. It didn't actually pick it for the calculation. But if we want those things to be matchy-matchy, we could come in and just swap out the asphalt shingles and felt for metal roof and Dens deck. And it won't change our compliance at all. It's based on the values we put into that Title 24 performance tab. Similar thing for the wall assemblies. We get to create and name those assemblies. So in this case, we called it an R21 wall with an R2 exterior insulation, but really, you know, we pick it, we call it that. It's the same thing. We have to go into the residential Title 24 performance, and then those layers will kind of default populate, but we could change them to make a matchy-matchy on the report. And windows, really similar. We, you know, the name was front windows, but we could call it, you know, window number 3, 4, 5. So we'll have some plans examiners specifically request that we name the windows based on the schedule that the architect gave us. So the plans examiner doesn't have to think and try and sort it out and go, wait a minute, they use front windows on the back wall? That makes no sense. So they'll often ask that the window name match the schedule, like window number 1, window 2, or window 02 to match how the architect has it spelled out. And in this case, we just name, you know, someone named the windows, good windows. Doesn't mean anything, just FYI, as a plans examiner. What really matters is the NFRC labeled U factors, and that comes from, you know, the manufacturer's cut sheet, or we pick just the basic Title 24 compliance baseline, and then if you have a lower U factor, a better window, then it complies. And then really the final step after we get a operating, up and running energy model is and it shows that the building complies for low-rise residential, and then soon, and for our multifamily, is we upload that Title 24 report to the Cheers registry. And this is then where the builder and the HERS rater and the installing contractors can access those other forms, and also where your plans examiner can go in, and your building inspector can go in and see that all the forms have been properly signed off on. So the report, once it's uploaded to Cheers, then we can download a watermarked version. And this is just what the cover sheet would look like, and shows, you know, the name, when it was calculated. This is a Title 24 analysis. It's a residential building, other important information like the climate zone, the address, the name of the building. And it just confirms that, yes, the building complies with the computer performance and there's special features and HERS raters needed. Next page will show the those energy design ratings, the compliance margins. In this case, we took the house was rotated in all 4 directions. That way, like for a subdivision, this house could be oriented any direction and it passes no matter what, and says pass right there in the middle. And then further down in the report, if nothing else, we love to remind the architects to please take this information. In this case, on this particular report, it's page 6. Sometimes it's page 3, 4, you know, sooner than page 6. But to make note of the required special features and HERS feature summaries. And we are encouraging people to get this onto their plans so that the builder and the homeowner and everyone involved realizes that a HERS professional will need to be contracted with, and that there are certain efficiencies that need to be confirmed on your heating and cooling system. And in this case, the Heat Pump Alliance, the Northwest Energy Efficiency Alliance NEA rated heat pump was modeled, so it's specific to brand/model or equivalent, must be installed. It's the last bullet point on the required special features. In this case too, it's called out that there's a variable capacity heat pump compliance. And also, this is where you will note if there's an exception to the PV requirement, which in this case, for this particular little house, the PV system was less than 1.8 kW, kilowatt DC. So no PV systems required. So this is important for the plans examiner to note. And if you need to know that, you can have the architect or the your energy consultant work with you to prove that it was really less than 1.8 kilowatt DC system. And then with that, we've got, for Grant had put this together for one of the local jurisdictions, and this is for the 2022 Energy Code, but we have a lot of support we can do for what to check on a CF1R for building departments. That's available. And of course, we are code coaches, so you can call us or reach out to us online, and we would be happy to answer your code questions. And with that, I'm going to turn it back over to Danica to tell you about some upcoming classes. And then we should have just a few minutes left for questions. And feel free at that point to either raise your hand or put a question in the chat, and then Grant can handle it. And there's a poll.
Yeah, thank you, Jennifer and Grant. So as we wrap up, please fill out this survey that I just launched. Let us know your thoughts and what other improvements and courses we should offer in the future. Do you want a similar course on non-res or multifamily? Do you want more courses on performance modeling in general? Our team is starting to think about our 2026 course lineup. So if there's a topic you'd like to see more of, please let us know in the survey. And next slide, please.
Okay.
If you have any questions with receiving your AI8 or ICC units, please reach out to my email listed on this slide. And in the next couple of days, you will receive an email with the slide deck and recording. If you're interested in the 2025 implementation code series that sorry, I need to sneeze. Um, um, if you're interested in the 2025 code implementation series that we've hosted this year, that entire series is available on our on-demand page. And if you'd like a deeper dive on HERS measures, I'd like to invite you all to our two-part series on this topic, which will be on October 8th, and part 2 will be on October 29th. And something that I didn't get to share with you all on the slides is that we published a blog to help you understand the AB 306 portions that were amended into AB 130. If you'd like to give that a read, I will put a link to that in the chat. And with that, I will pass it back to Jennifer and Grant for any last questions.
Yeah, anyone send in any quick questions you have? We had a lot. The chat was busy, which was always fun. But I think we hit on most of them. If I missed one, please chime in right now and we can go backwards and talk about any other topic. Thanks, Matthew. Yeah, this is kind of one of the first ones we've even dug into the modeling because we've really focused on codes and standards, implementation, that kind of stuff for 3C Ren's programs, knowing that Energy Code ACE offers so much great modeling content. But something we're definitely gonna talk about and see if there's a need for more coursework of this kind of type. Anticipate modeling changing soon. I don't. Jennifer Jacob asks if we anticipate the modeling changing significantly for the 2025 code cycle.
Well, okay, so I haven't played with the software very much yet, but I did do, our kind of the internal training for those of us who are energy modelers with CBECC, with some of those folks who are digging into the new kind of climate zone specific numbers that they use to establish the performance calculation, and those metrics have changed. And what folks who've been playing around with the software more than me have noticed is that there is there's more now emphasis on the building and when the cooling is taking place. So if the cooling is taking place during a time when there isn't a lot of low carbon renewable energy feeding the grid, there might be more of a penalty, so to speak. But I don't know anyone yet who's played around with the software enough to know how that might impact our designs. But the input and how we do the information into the software really isn't changing.
Yeah, Matthew chimed in saying, hey, Energy Pro is going to come out with V10 for the new code, but only minor changes. Typically on a new code cycle, the new version of the software, be CBECC or Energy Pro, they might clean up some old inputs, add a couple new inputs, maybe give us some new library stuff, but the process and how it looks and the tree and all that kind of stuff will remain the same. Kimberly asked if there's available testing software we can play with. I'm assuming for the 2025 code. Is CBECS out yet? I know we're like on the cusp of it.
Yes. I just downloaded the CBECC stuff and have been playing around with that. And I've been using it for a couple projects I know that are going to be in the new code cycle. So yeah, you could start playing with it. I haven't messed around with Energy Pro yet. but CBECC I have, and you can get that off the website.
Yeah, and then Thomas asked if the software takes into account thermal mass. My answer is not really. No. I know old versions of it tried to. What do you tell people these days, Jennifer?
It's built in. So if you do slab on grade construction in a residence, for example, it takes that into account in a sense. And there's a certain amount of like thermal mass built into the project, but it's not modeling for compliance. It's not modeling whether or not you're using like a phase change drywall material, or it's not really modeling if you have a lot of heavy mass interior to the space. And there's a history behind it, and part of it is that yes, you can use it as like a thermal battery thermal storage to save energy, but it's very narrow to certain climate zones that get enough of a diurnal swing at night and day to use it for the cooling. And then the heating, once all the home gets up to temperature, you want a well insulated envelope. It's like putting a hot water bottle in your jacket and then putting a really good parka around it. It's not so much that water inside your jacket was hot to begin with. It's that your jacket is super well insulated, that is keeping you warm. And so what we found with energy use overall is that a better way to get more projects, more homes, better efficiency, and use less energy is with new technology we have, which includes all the new windows, double pane, dual pane, triple pane, better air sealing techniques, better insulation, and are available. And so all that is helping your buildings be more energy efficient, more effectively than the old school, which was to load up the building with lots of thermal mass and very little insulation and single paned windows. So we've kind of morphed into, better insulation, but the thermal mass still works. It's just, you can do it. It just won't show up as a credit on your Title 24 report, but it still works.
Yeah,
You'll just have a more efficient building or a more comfortable building than
and
a code
when I
compliant.
have clients who are looking for the older passive solar design, the trying to quantify the benefits of a trom wall, of that mass with significant shading and all that stuff, the Title 24 compliance software is not the best tool for it. It's not going to capture what potentially could be going right and what could be going wrong. It's just not designed for that.
Yeah, that particular software for compliance is, hey, if you do this amount of insulation and you air seal it and you do your QII and you have your HERS rater come out and you have it's per climate zone, but it's showing this building will comply. And if you want to go above and beyond it, you totally can. And that includes like the thermal mass, the passive solar aspects, you can. And it captures it to a certain degree.
Right.
And for example, you can have a slab on grade, insulate your slab on grade, and you can use that. I've modeled a lot of houses in a variety of climate zones, and you can have more than the prescriptive kind of baseline amount of south glass, and you can get yourself more fenestration, more windows, go with triple pane, fine tune the U factor, the solar heat gain coefficient and all that. And you can have a house that's more glass than a standard home, and you'll still be comfortable. It just, the comfort factor doesn't show up in compliance software. That might be a long way to answer it, but I think the question was getting at those comfort things and the passive solar side of it. Let's see, we have a couple more questions coming in.
Nancy, I'm so sorry. So, Danica's gonna laugh. She asked, "Where can I find a list of certified HERS raters?" Danica, you want to speak to it? You have the inquiry and inline into what happened.
Yes, we actually reached out to Cheers. Previously, they had a zip code lookup function where you put in your zip code and it would show all of the HERS raters that are within that zip code or work in that zip code. However, now they don't have that feature anymore. And what they've recommended us to do and recommend is to use Google or Yelp to look for certified HERS raters in the area, which
Wow.
unfortunately is not not the best way to do it, but that is what we have at the moment.
They have a lookup tool by first and last name, I believe.
Yeah.
That they replaced it, and yeah. So if you find a couple, yep, there's one. We got one in the chat, so you can look up the HERS rating company you find and see that they have active certs, but no longer do we have a list from Cheers, unfortunately. We need more HERS raters advertising everywhere. For every HERS rater in the call, please. And more people, we just need more HERS raters. Period.
Yeah, that
Uh,
does seem to be a common theme.
Yeah.
Okay.
we are over
we
time, so
okay? Yes.
uh, if there are no more questions, I'll go ahead and end the meeting and see everyone next time. Thank you, everyone.
Thanks, everyone.